DeepSeek was a wake-up call to both markets and politicians around the world who weren't paying enough attention to China's success in AI. Now, that success has been very clear to those who have been paying attention. China's AI models, not just DeepSeek, but many of the other models that have been released, have consistently been climbing the charts in terms of performance. They're using this, what they call a mix of experts model that's much more efficient to train. So I think that was part of it. The other part is that DeepSeek also really climbed the charts in terms of customer adoption. It was the #1 downloaded app on the App Store for a number of days. So I think when people saw DeepSeek doing this as well, having that same kind of market trajectory, people realized that this wasn't something that could just happen once with ChatGPT. A better performing AI model could come out, a better performing app, and quickly displace it. And so what we've seen on the political side is there's been a lot of questions raised, particularly in the West, about whether they're doing enough to support the development of the AI sectors in their own countries. We're seeing this. We've seen this play out in the United States, in the UK, in the EU. Policymakers there are saying, maybe we shouldn't think about regulating so much our sectors because maybe we're holding them back, and maybe we need to be making sure we're doing everything we can to be competitive. Well, its strength is clearly that it is faster and cheaper than anything on the market, and cost is really something that's been underappreciated. One of the reasons that I think DeepSeek got so much attention is not only because it was such a highly performing model and it came from China, where most of the innovation in the past people were looking at as coming from the United States, but the fact that this model is able to be trained using less fewer chips at a faster pace, and also just once the model has been created, it's able to do inference, so it's able to create results much cheaper than any of the other models on the market by a significant magnitude. And that really matters. If you're a developer creating an app or some kind of service and you're integrating AI, those costs impact your own cost and the cost of the services that you deliver to your clients. It also does well, in terms of the fact that it's open source. So because it's open source, it's an open model, the weights are available. People can download the code, they can download the model weights, and there's some freedom there to modify it that you don't have in some of the closed source. Well, I don't think there's necessarily huge divergence yet. Both on the US side and on the Chinese side, we are seeing developers pursuing larger models and developers pursuing smaller models. So for example, on the US side, Microsoft has done a lot of innovation around very small models. They focused on what's called pruning the model. So if you take a large model, think about it like a large bush. You take out all the parts you don't need. So you have a smaller one that's still very effective. It achieves what you want it to achieve in terms of performance and accuracy, but it costs significantly less to run. But that said, I think many companies are looking at DeepSeek's success and wondering, can they do the same thing? There's just so much more competition now. There's already been a lot of competition in this space, but when you see a new company that people weren't really talking about as much just explode onto the scene like this, it changes the game. Well, I don't think any company has been able to, gain what you might call a durable advantage, an advantage that will allow them to remain the market leader unquestionably, for the next year or longer. Instead, there's just massive competition. If you look in the United States, for example, it's not just OpenAI, right? With ChatGPT, you have companies like Meta, Google, Microsoft, Amazon, Cohere, Anthropic, all developing very capable models. Not to mention, just other startups in the space. You have Mistral, in France, and you have companies like Midjourney in the UK. There's lots of innovation in this space, and so right now the question is basically nobody knows what the next. You can think about like basically a computational paradigm for these models will be. So many companies were focused on this idea of the transformer architecture network. That's how they built ChatGPT. That was something that Google came up with, and then OpenAI, of course, ran with that concept. But we don't know what the next technical underlying solution will be that leads to better performing models. It could be that it's they're just focused on optimization and this mix of experts. It could be that bigger models are actually better over the long term. It could be that you need to be focusing on better data, and the companies that get higher quality data for specific issues, they're going to be able to solve things better. Or it could be something that we're not even really talking about today. ChatGPT has passed the Turing test. It is indistinguishable in a conversation between a human and a computer, where humans can't tell if they're talking to a human or a computer. But that said, even though we've had this massive scientific achievement, and AI is very good at certain specific tasks, but even though it can do all that, it's still very far from human intelligence. Right? It has no understanding, for example, of the physical world. For the most part, it doesn't have long-term persistent memory. It doesn't really, have emotions or recognize emotions in the same way that humans do. So it's very different from human intelligence. And so even though we're seeing, again, massive advances, we're still a long way from this idea of a computer, basically being a substitute for a human. There are areas where it is very effective. We should look for those opportunities to leverage the technology. And again, if you think about the jobs that are going to be most impacted in the short term, it's going to be things like programmers, especially more lower level junior programmers who are writing code that now these AI systems can produce very efficiently, effectively, without errors, without needing to be debugged. With AI, the benefits that are out there. I mean, this idea that we can live in a world of abundance, that's incredibly powerful. That's something that we should be striving for, and we should really be trying to accelerate that type of progress. If you think about the potential diseases that might be cured with AI, I mean, that's something that will impact people alive today, right? This is something that we should be, again, pushing for quickly. The loss of control is really, I think, it's more science fiction than reality. The truth is, when we build these AI systems, they're not fully autonomous. We still have control over them. And as we build them, we put more and more controls into place. There's not really a risk of AI taking over, kind of the way that we've seen in various movies. I think that's something we obviously always have to think about. We have to consider the unintended consequences. But the reality is, these types of issues are top of mind for AI developers. And so we're not proceeding blindly. We're thinking about these types of risk, and government's thinking about these risks, and we're tracking the changes. And so the real risk, I think, for us as a society is that we don't get there as fast as we could, and that there's a significant cost to that. And so I think that the focus should really be on how do we accelerate AI development? How do we accelerate adoption? There isn't just one type of competition and one pathway for innovation in AI. We're seeing lots of different pathways, and we're still not sure where that kind of final destination is, how effective some of these models will eventually get. I do know that, if you look at the history of technology in these spaces, there's two things that are stand out. One is that performance always improves over time, and it's a combination of hardware and software. And two, efficiency improves over time. Just throughout the history of computing, the cost of storage, of compute, all of that has gone down over time. And the pace at which that has gone down has sometimes been just staggering. And so with AI, the question that I think we're really faced with is, will the advances in hardware and software come at the pace necessary to allow us to get to kind of a next generation AI, AI models that are 10 times larger than they all are today? Or are we kind of peaking in terms of the hardware capabilities, and that we really need to focus on the optimization side? That's the part that I don't think we really have the answer to yet. And that's one of the reasons the next few years are going to be very interesting, because the question is basically, are we going to get faster, better chips that allow us to do significantly more? Or are we going to be kind of hitting that peak